ladies and gentlemen. Did you guys hear that echo? Yeah, I think I know why. The echo, because it's playing through the speakers. Anyway, I don't know. Not sure how to fix that, but it's okay. Does it kind of bother you, the echo? It's kind of weird, but anyway, let's take a look at some material here, because I was thinking about it yesterday, like, man, this echo's going on. I might be able to, yeah, let's just do that. Okay, now the echo's gone, is that right? Let's see if we still have the sound. That sounds a little normal. That sounds better. Oh, wait a minute. I hear the echo here. Now, anyway, whatever. Why is there... I don't want to get too ahead. Okay. I think we call that A, B, C. Then you have this little a, little b, little c. Okay. Now, if I go back to my, I'm going to take a look online here. 241. Let's see the browser. Worksheets and videos here. I do have a worksheet, and of course you guys have that bookwork. Law of cosines, right? Do you guys see that there? Law of cosines. So here we have angle, side, angle, and side, side, side. So I want to share with you guys here, this is what I kind of wrote down for you guys. This is, again, law of what? Our law of cosines here. Let me double check. Yeah, okay. So when I go to the iPad now, you know, I want you guys to remember when you have a case called angle, side, or side, side, side. We get to use what's known as law of what? Cosines. Going back over here to the browser. It's these formulas. Now, I want to illustrate to you guys really how to memorize this so that you know, how, but there's an easy way to use it. Okay, yes, you might say, oh my God, what does this formula look like to me? Okay. What are they really saying in these formulas here? All right. It's a bit like Pythagorean theorem. You see, let's say, for example, you have angle, side angle. And what does that actually mean? Angle, side angle. So if, for example, you have, oh, what? Angle. Oh, I'm sorry. There's something bothering me about this. What's bothering me? It's not. It's side. It's a little dyslexia. It's actually side, angle, side. I apologize. Okay. No wonder it didn't make sense. I was like, wait a minute. This is law of sines. Okay. So here's what I want you guys to see here. Okay. Law of cosines is going to apply for side, angle, side. What does that side, angle, side mean? Yes. Oh, you guys can't. Oh, this is. I apologize. There we go. Sorry. Say, what's going on? Okay, there we go. It's when you have side angle side. I apologize, or side. So we're going to focus on the side angle side for you guys, right? And notice what I mean. Here's side. Here's what they're saying. What if you have side B, angle A, side C? So the angle is included. This is called an included angle. And this angle is between two adjacent sides. So you say, what angle? Well, A. A is between two adjacent sides, just to let you guys know. So what's really going on in this formula here, it's kind of like Pythagorean theorem. You see the opposite side A there? Okay, you guys with me on this? I want you guys to focus on that little side A. Here's what I mean by that. What law of cosines says, if you go back here to law of cosines in the browser, they're really talking about, let me scroll down, the second line here. Because you say, Mr. Judge, how come they have 3 versions? Yeah, there is 3 formulas. But let me simplify it for you guys, okay? So I'm really talking about the second formula, but I'm going to simplify this. Because it's actually a real easy thing to do. If we kind of think about, Pythagorean theorem. Here's what I mean by that. You have the side angle side situation. Okay, you see A that's red there? Law of cosines really means this. If you know one, you know the others. Take that A squared in red and then take the 2 remaining sides. So this is what I mean. It looks like it's Pythagorean theorem. But be careful. This is A. Okay, that's unknown. And it's A squared. And then you got B squared and C squared. Those are known. All right, for side angle side. And then you say, well, what else is there? Well, it's minus 2BC. In other words, it's not Pythagorean theorem. There's more to it, 2BC. And then you say, well, why do they call it law of cosines? Because you're going to have now cosine of what? The angle A. So everything here on the right side is known. I might prove it to you guys tomorrow, show you guys where it comes from. But it's a very simple formula to apply. It looks complicated, but you got to use your calculator. Now remember, this is side angle side. This is what I'm saying. We're focusing on this situation. Side angle side. Okay? It always gives us a way to find that opposite side little a. This is the law of sines formula here. Law of cosines. It's a very simple pattern. We're looking at the pattern here. So if you said to me, okay, Mr. Judge, let's do this here. What if they gave us side angle side again? You say, what if they gave us 2 sides and an angle? Now they gave us a, little c, and then big B. Right? We're going to deduce again this formula here because you have 3 formulas. But you really only need to know one. They're going to ask you again for the remaining what? Little b. Okay, in red. So law of cosines will say what? Start with that little b. This is how I remember it, ladies and gentlemen. Start with this little what? B. And square it. Start with the opposite side of the angle. And then what are the two sides that are given? They're given a and c, right? So this will be now a squared plus c squared. Because those things in blue are given to you guys. And what happens is this is going to be minus 2b, 2ac. The sides that are given, Everything on the right is given to you in blue. And now this will be cosine of big B. It's, again, opposite the little b. So everything in blue is going to be given to you guys, and this is known as the law of cosines. It's going to enable you to find that side little b. Easy peasy lemon squeezy. It's a way to think of this formula here. So this is always, again, when they give you the situation of a side, angle side. Yes?
So the first one was if they give you a side, angle, side.
They're all three of these that you see here, we're going to do three, are side, angle, side. So all of these are this first case, side, angle, side. But I want to share with you guys how to look at the formula and how to use it. So notice now, I'm going to do another one here. Here's what I'm going to do here. What's given to you, again, is in blue, side, angle, side. So if they give you side, angle, side, opposite the angle is little c. It's a formula that's pretty simple to do. So again, they gave you side, angle, side. All of these are side, angle, sides, where the angle is between two adjacent sides. So c squared, that side here, ladies and gentlemen, is going to equal, you say, what is that going to equal? What did they give you? What are the two sides they gave you, A and B? So what is it going to be? A squared plus what? B squared. And then don't forget minus 2AB, those same sides. And that's going to be cosine now of angle C. So that's opposite, the opposite angle to side C. So notice again in blue, this is the pattern for the formula. It's a very simple formula, but you know, it has some things to think about. This is called law of cosines. And you know, we can prove it, but not today. But we're going to use this here. Just going to get something up and running here. Oh, come on. Okay, so ladies and gentlemen, let me show you guys how to use this as an example. These are your law of cosines formula here. So we're going to start simple. $38 meters. That's 38 meters, and then maybe 21 meters. And then you have to have a what here? Right? We're going to have an angle that's what? Anybody know what I'm talking about? We're going to work on the side, angle, side situation here. Okay? Now, just for simplicity's sake, we'll say A, we'll say B, and we'll say C here. So that makes this little c. You know what they're going to ask? They're going to say, what is little c? So here's my point to you guys. Side, angle, side. they're going to always want the opposite what side here? Notice they ask, what is little c? So, how do you go about this, ladies and gentlemen? What do you think you do? What do you say? Little c squared is equal to what? How do you do this? What were the given sides? 38 squared plus 21 squared, okay? Minus 2 times 38 times 21. Times what? Anybody want to tell me? This is law of cosines. Cosine of what angle? Which is 80 degrees, is that right? They gave you these things. This, 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 this. We'll see. So you now say they want c, not c squared. You guys know what you do? What is c then going to be? Do you guys remember the square root formula? You take the square root of what? All of this. And I know you might say, Mr. Judge, isn't that plus or minus? Well, it would be, right? Do you guys remember the square root? Didn't we work on square root formula too? You say, wait a minute, we did square root formula here. Okay, what do you do with that? Why do we get rid of the negative? Anybody remember? Because distance is not negative here, right? You don't have negative distance for c. So what I'm saying to you guys is this can be very, very easy to do when you have your calculator here, right? And we'll be using our calculator for this. So you say, okay, well, how do we use the calculator? Here we go. That's going to be, remember, second radical, what's this? 38 squared plus 21 squared minus 2 times 38 times 21 times cosine of what? 80. It's 80 degrees. Okay? So double check, ladies and gentlemen. I entered everything here the way it's supposed to be. What do you think happens when I hit enter? We're going to go out to the nearest whole number. What is this going to give us? Isn't C going to be approximately what, 40? Come on. And there you go. This is by law of cosines. And very often, they're going to want you guys to actually do that here. So if I said to you, now, what is angle A? How do you guys think you could get angle A? Right? I'm going to remove this here. No. How could you get angle A? Well, there's a couple of ways you could do it. There's a couple of ways. How would you get angle A? I mean, you answered the question. They want you to find that from side, angle, side. They want you to find the opposite side of C, the opposite of the angle. It's a very common question. Very common. You could use law signs or note. Let me share with you guys another thing. Right? Isn't it true the formula for little a squared is b squared plus c squared minus 2bc cosine of a. So what your book is going to have you guys do here is solve now. And if I said, what is a? Let's color that red. Yeah, it is red. What is the angle? Here's what your book is going to suggest for law of cosines. Because everything else is given to you. Is that true? Can you solve, first of all, this? I want you guys to do this. Can you solve for cosine A? The answer is yes. How do you guys solve for cosine A? Do you guys know a quick and easy way to solve? Do you guys know what this is? If I move these lines, who knows what this is? It's called translation, moving terms. So if you move terms from the opposite side of an equal sign, right? So what I do to quick and easy solve is on the left side, 2bc cosine A, I'm going to quickly solve this, is positive. So if I move a term, you say, what terms did I move? I moved this term. I want to get a highlighter in gray. I moved this term over here. I moved the term on the right to the left. What happened to the sign? It changes. It's opposite. I moved the a squared term to the other side. What happens to its sign? It's opposite. Here's my point. Look at the signs now. They're opposite. Okay? It's called translation, or you add them to each side. That's all you're doing. It's shorthand for adding or subtracting a term. So now I can solve for cosine A. What's cosine A? Right? Divide both sides now by the 2bc. Just using algebra. And then what happens here? Cosine A becomes what? B squared plus c squared minus a squared, everything over 2bc. This is by law of cosines, ladies and gentlemen. This is going to enable you to find angle A. This is what the book says you can do. The book wants you to have this version of law of cosines. So that you might say, now, what does this mean for me? Well, it means cosine A, remember, everything on the right here is going to be given to you. So it's in blue. So if I go back and I say, I need to know what B and C are. You say, what's B and C? Oh, okay. So this will be B, this will be C. Is that true? So B and C, 38 and 40 here. Okay, 38 and 40, B and C. So 38 and 40. So, oh, what is that? Okay, let's be more specific. Little b is 38. Okay. So we say, okay, that's 38 squared plus 40 squared minus, what's that little a? We just found that, I think. Yeah? Little a is 21. So it's minus that 21 squared over 2 times that b and c. So it's 38 times 40. So what I'm reminding you guys is simply this. is going to be there. Now, it gets better. Anybody know, what do I want to do with this now? Because I need angle A. I'll tell you what I do. How do you get angle A? You're going to have to use what? I'm going to put this in red here. Use inverse what? Cosine. We might have to do a whole bunch of inverse sine, inverse cosine things. Inverse functions. You guys remember inverse functions? I think we might have to do a little worksheet on that. They'll do a little S on this stuff. What do I mean by inverse cosine? You have to do some S on inverse cosine. Doesn't this mean that A is inverse cosine of all of those numbers that we have here? You guys know what I'm saying? This is what the book wants you to do. If you look at that book on law of cosines, your book is going to go through this detail, inverse cosine. So we might have to do some S. How do we get inverse cosine, inverse sine? There's even inverse tangent. We'll see that in our future. But the point I'm making here is this is how we get angle A by law of cosines, using a little bit of algebra. So when you go back and look at the example of the book and you go, how come they have all of it this way? Well, second inverse cosine, that's blue. And you know what I do is I'll put a parentheses for the numerator, work. So 38 squared, look at that parentheses here, plus 40 what? Squared minus 21 what? Squared, and you close that. There's my numerator here, right? And then you have divided by what? Parentheses again, 2 times 38 times 40, and then you close that too, but you got to close it twice. So I want you guys to go back. Let's take a look at the iPad, and we're going to look at this calculator again because it's an important detail. We put this numerator here in another set of parentheses. We put the denominator here with another set of parentheses here. And yes, this is inverse cosine. So let's take a very close look at the calculator. Okay, so I'm going to take a close look at that calculator and have you guys double check. Maybe I could go back here. Right? Is this inverse cosine? Yes, it is. So notice that I have a parentheses already for the inverse. Then I have the numerator in its parentheses. Division, that's divide by the product in the denominator in a parentheses. And what do you guys get? What's the angle? If we go out to the nearest angle, what is this going to be? 31 degrees. Ladies and gentlemen, I guess that was red. It's now blue. We know what it is. Angle A is 31 degrees. So this is known now. This is using law of what? Cosines. And guess what you can now really do? Now we can find what? Angle B. How do I know what angle B is? 180 minus 80 minus 31 degrees. I can get the remaining what? Angle with the fact that the sum of the interior angles for any triangle is 180. So you say, well, what's that going to be? Well, let's take a look. 180 minus 80 minus 31, 69 degrees. So this is the approach that you use via law of cosines. And ladies and gentlemen, you're still able to solve a triangle, but this is what's called side angle what? Side. So whenever you have side angle side, this is going to be the procedure that you what? That you use. Right? You guys see what I'm saying? So if I look back here online here, and let's look at this here, assignment here, right? Where are you guys at? Let me get that here. Browser, we need browser. You say, why is that kind of important for us now? Because remember what we're doing last time. Law of what? Law of cosines. And so, we're giving you kind of a supplementary lesson, since this is a supplementary course, whatever that means. And let me do again, I'm going to change something on you guys. Here. Okay. We're going to give you another example here of law of cosines and, why we care about this again. Because we do care. We care. There's a reason why we're doing the inverse function, because it helps us find angles by law of cosine. So I'm going to make sure I get something from your book, because I don't want to. Come on, where are you? Okay, so here's another example. And if they said to us, okay, this measures here. Let's do it this way. Yeah, let's do it this way here. Okay, let's draw a different picture for you guys. Of course, A, B, C. This is now 110 degrees. This is 16, and this is 20 here. Okay? What I want to make sure that's clear here for you guys on this is you have side, and the angle is between two sides. This is, again, side angle side, right? That's the abbreviation, side angle side. The angle is between two adjacent sides. This is between this A. It's between two adjacent sides. All right, you guys okay with that? Now, over here, this would be little a. Is that true? Whatever letter is opposite the angle is that little letter. So this is little c, and then this is little b. Now, I want to remind you guys, law of what? Cosines applies to side angle side. So you must be given side angle side, and then you get to use law of what? Cosines. Now, for me, like I said, yes, you could go back, and it's in your book, it's in my notes. I showed you guys, shared with that yesterday. Said, you know what? This is really law of cosines. There's 3 equations. But I'm going to admit to you guys, I don't like to do a lot of memory. I have to do some memorization. I don't memorize these 3 formulas, really. You know what I memorize? I memorize the process, really. This looks to me, like I said yesterday, you see these terms? What does that look like to you guys? To me, that looks like Pythagorean theorem. like a version of Pythagorean theorem. It's not Pythagorean theorem, but it looks like that to me. So I can very easily apply law of cosines in that way. And you say, what do you mean? Well, in this case, A, you start with that A. That means A squared equals, this is now the sum of the legs, B squared plus C squared. Okay, you guys with me on that? That's what it reminds me of. But I do some memorization, I have to admit. In other words, notice this, right? The A squared, it's the legs, B and C. So that's minus 2BC cosine of that big A. There's a relationship. The angle A and the side A. But I got to use the legs. This is minus 2BC now. So minus 2BC, I have to write down. So it's minus 2BC, and then it's cosine of angle A. So it's a very simple thing for me. And then you might say, well, what do I do with this now? Well, this allows you to find A. That means side A. Everything else is given. So that means A squared becomes what? 16 squared plus 20 squared minus 2 times 16 times 20 times cosine of 110 degrees. Okay? What is A? A is the square root of what? All of this. Okay, so you're using like the square root formula there. And remember in your calculator, you know, this is really what you're going to answer. So it's kind of, again, you're going to have to go with that process of entering these things here. Second square root, and then you have this is 16 squared. There's a square key here. There we go. Plus 20 squared minus 2 times 16 times 20 times cosine of what? 110. Close that, ladies and gentlemen. And guess what you get? This is the value for it. We're going to go to the tenths today. I feel about being a little bit more accurate. You know, 29.6. That's not an angle. That's a side. That was A. So A, this value is 29.6. Here's what they want us to do. Right? So, I mean, we found that side, but then now you might say, okay, Mr. Judge, you know what they're going to do? They're going to want me to solve the triangle. What does it mean to solve the triangle? It means get the other angles now. You got all three sides, but we need now the other angles. And you say, well, how do I get the other angles? Pick an angle. Which one do you want to use? You want to try to use B? Let's use B. Okay? So here's what I'm going to do. I'm going to share with you guys again the process about how to do this. Okay? This is known, and what is not known, I'm going to color red now. So here's what you do. You say, well, what do I do with this? Okay, here's what you guys do with this now, right? I'm going to use the same process I did before. So the same process before, if I use law of cosines, right? I know that's red. What's the relationship, right? This now means using law of cosines. This here is little b. Do you guys agree with that? Because it's opposite angle b. I have to use the version of law of cosines that has b squared now. And that equals a squared plus c squared. That's the Pythagorean theorem portion, I say. It's not really Pythagorean theorem. It looks like it. But then this is now 2ac. This is cosine of what? B. So I'm using law of cosines. But B is unknown. Everything else is known now. So I can color this blue because I know that side is known. Okay, you guys see what I'm saying? What's known is what is not known is the angle. And if you go back and you look at this law of cosines, you go, oh, where is the formulas? Could I use that one? The b squared is a squared plus c squared minus 2ac. Cosine of b? Yes. You got to use that. So that's exactly what we did. Now fill in the values. Okay, you fill in the values and you get what? 16 squared. Isn't that b? Okay, we got a, which is 29.6 squared. C, 20 squared, minus 2 times 29.6 times 20 cosine of angle B. That's what you guys do. So what I'm going to remark to you guys now is use, what did I call this yesterday? If I move a term across the equal sign, I'm going to move 2 terms. What happens with the sign? It's opposite. This is actually solving for eventually cosine B, really. Algebra. 2, 29.6 times 20 cosine B will equal 29.6 squared plus 20 squared minus 16 squared. Okay, you guys okay with that? It's called translation. And then what are you going to divide both sides by? Do you guys know? You divide both sides by 2. 29.6 times 20. 2, 29.6 times 20. So you get cancellation here and here. So you end up with that cosine B, ladies and gentlemen, equals what you see over here. It's cosine B. So in other words, I'm using algebra. And then now this comes back to another thing I'm going to say to you guys. What this really means is if I solve for B, this is why we did the S portion this morning. What can I do now? Do you guys see what I'm saying? What is B going to be? The inverse cosine of, I think this morning we colored all of this what? Gold or whatever color this is. I don't know what color. A high percentage of men are colorblind. We don't know. We don't know. That's why our clothes don't match. I don't know. Is that gold? Brown, maybe? You see what I'm saying? So I'm going to move this down. So this is why we did what we did this morning. Copy, paste. But in the calculator, let's go through some more detail here, okay? because I want to highlight exactly how you go about this. It's not too bad. Just simply use again here or what? Our parentheses. And of course, B is an angle, so we're going to approximate this today to the nearest tenths here. So let's punch that in, okay? So we're going to punch that in the TI, and we're going to get this answer here for angle B. And I'm going to clear this out. And I'm going to say, oh, I need inverse cosine, add another parentheses for the numerator. 29.6 what? Squared plus 20 what? Squared minus 16 squared. Close that. Divided by 2 times 29.6 times 20. Angle B is 30 point what? 5 degrees. There it is, ladies and gentlemen. 30.5 degrees is angle B. So this is why we learned or reviewed this morning how to use our calculator so we can actually use it in this case here. So this is B. This is 30.5 degrees. And then finally, to solve the triangle, what else can you guys do? What do you guys think? Now, easy breezy, lemon squeezy. What am I talking about? How do we get angle C? Right, the sum of the interior angles is 180. You know what that means? 180 minus 110 degrees minus that 30.5 degrees will give us the angle we need. Okay, you guys okay with that? So let's go through the calculator again. Say, okay, TI, where are you? Here you go. And 180 minus 110 minus 30.5. What do you end up with? You end up with 39 point what? 5 degrees. Is that true? And so, ladies and gentlemen, that's what you do here. This is how we solve a triangle. We got to get all that information. Solving triangles is important. So you're learning some skills, law of sines, law of cosines. Okay, so this is kind of a review of that formula from yesterday. And then what that now does for us, let me get back on this other computer that always logs me out. If you snooze, you lose. The last remaining triangle we have to solve is the side situation. Right? You might say, what do you mean? Yeah, this is going to be side. Angle A, angle B, side. So if they give you 60 here, 122, and 155. This is what I mean by side. What did they give you? They gave you 3 sides. You know the lengths of all 3 sides, but you don't know the angles. So what do you think they're going to ask you to do? They're going to ask you to determine the what? All the angles now. And you go, oh no, we're going to have to solve the triangle. This is a side situation here, okay? Side. So, how do you think you have to do that? Let's have that open for a little. Thank you. We have to close the door because we need some silence, right? you so much. Unless we leave the door open, then we hear everything that goes on in the hallways and everywhere else. You know, supposedly, which you guys don't know, this whole system we have here. You know, I was at a meeting yesterday because what the school has finally decided to do is do exactly what I'm doing. What am I doing? Do you guys know? I'm broadcasting for students where at home or in class and recording the lecture. So the school, what you see here, all this technology that they placed in these classrooms, that camera and all these monitors, is because they're doing what I'm doing. They spent a lot of money to do it, more than I did. So, huh? Do I want the money? Not really. I kind of don't. How do I put this? It's not my motivation. It's I've been recording videos since 2008. That's when Khan Academy started. Khan Academy, they're rich. I'm not. My videos are online for free. They're not for sale. Some of you guys are probably born in 2008. So, you know that I've been doing things for different reasons for years. Anyway, point being, they've decided to kind of do what I'm doing. So I've been doing this broadcast stuff for a while. They finally got a clue. But that's the way it is. So no big deal. So what am I telling you guys? Oh, yeah. That's a camera. So there's a system that they're going to have, so they're going to have people lecture on the board if they want. And the camera follows the instructor in the board. That's a camera. There's microphones. You say, where's the microphones? You see that right there? In green, I think? Those are microphones. You can't see them, but they're in there. Well, they're in that, whatever that device is. And then the round things are speakers. There's not a lot of speakers here. There's only like 1, 2, 3, maybe 4 speakers. Speakers, camera, and, microphones. So anyway, they told us yesterday that the microphones can pick up all the noise like outside the room, in the room. Conversations, you name it. So they're probably listening to us right now. Anyway, I've been broadcasting for a long time, ladies and gentlemen, so they finally got a clue. Oh, no. Isn't that kind of interesting? You guys a little bit of trivia for you. A little bit of trivia. Could you guys imagine? It's insane. Anyway, how they're going to do that is they're going to do it over Zoom. So the broadcasting part, this is the physical attributes, but they're going to broadcast via Zoom. In other words, that's how you actually view it, is now in Zoom. And that's going to be in your future. So future's coming soon. Maybe by fall, I don't know. It's called HiFlex. So you guys get to sign up for courses that are now just like Mr. Judge. Maybe. Anyway, whatever. Any class now, really. Any class. Not just math. Well, most classes. I don't think science classes do that because you have labs. But who knows? They might want to do something similar. So anyway, there's a lot of little changes coming. A lot of changes. Interesting idea. We live in an interesting time. In some ways good, and in some ways what? Bad. People have more technology but less skills. Except social media. I guess. I don't know. And in fact, people are more depressed than they used to be. You guys are depressed? Some of you guys look depressed. Yes. More technology has led to more depression? Social media? You guys get sad when you look at people having a good time on social media? I do. I've been sad my whole life. Join the club. Social media makes me sad. That's why I'm not on it. Anybody here on social media? What's the best social media? TikTok? Is that what you like, TikTok? Is that your favorite? Most entertaining is TikTok? Do you ever get math videos in your feed? History. Do you look up history things? No. Do you guys know? You guys probably, there's an algorithm on you. Do you ever notice that? Anybody have a spending problem? Because you're bombarded with all the things you like to spend money on? And they know you already. They go, this person likes shoes. So all you get is shoes in your feed? No? What do you guys get in your feed? McDonald's? No? Do they know you? Do they know you went to McDonald's this morning? Yeah, they probably know, right? Isn't that crazy? Wow. People are more. Things are more convenient for people, yet they're more depressed than ever. That's weird. Don't know why. I don't know why. It's weird. I would say then get off social media. Don't get on social media. Put your phone away. Throw your phone away. What, $1 million? What do you mean? If I want $1 million? What if he said that on post or something like, I want to bring people in? Nah, doesn't happen. I hate to break the news to you. People don't do things really. How can I put it? No. So, how can I put this? You're not gonna get $1 million for no reason. You know. Anyway. So now you guys know what's going on with this technology and what's coming. And let's ask you guys this question. Would you rather be in class or would you rather be at home? Yes. Me too. Why? You got the refrigerator. You're always going to the refrigerator, getting some ice cream. No? When you wake up, you get ice cream or something. And then your bed is there, and you say, I'm just going to lay on my bed. What else? It's loud. You got the dog barking next door. Maybe your dog barking too. You got the lady down the street screaming. Maybe it's you screaming. I don't know. You guys know what I'm saying? At home, don't you have a lot of noise? There's arguing, pets, kids, you name it. It's good to get out of the house. It's good to get up and shower. It's good to brush your teeth and shave. It's good to hit the road in the morning. Staying at home is like a drag. It can be. So I don't know. You think people are going to opt for classes where they're remote, or are they going to opt for coming face-to-face? What do you guys think? Don't know. Some people are going to do remote. Some people are going to do face-to-face. It's convenient when you need it. When you need it, it's convenient. You got a video. Hopefully the instructor records the video. It's convenient, but I don't know. And just, it seems as if the more convenient you make things, the more depressed people become. The more entertaining you are, the more depressed they become. It's weird. Entertaining in some ways, I guess. I don't know. Do you ever look at social media, somebody's in Hawaii? And you're like, man, I wish I was in Hawaii. How come I can't be there? They look like they're having a wonderful time. Yeah, that's how I get. Like, man, why am I here? Can't wait to get to Hawaii. Can't wait to get to Maui. Then I see how expensive it is. Like, oh my God, it's $1,000 a day? I want to spend 10 days. That's $10,000. A lot of money. Horrible. Weird. Anyway, let's get an angle. How do we get an angle? Which angle do you guys want? Angle what? All right. How do we do that if we want angle A? We're going to have to use side A. Remember that formula? Law of cosines. This is the last example for law of cosines, meaning you say A squared. What are the other sides? B squared plus what? C squared minus 2BC cosine of what? A, ladies and gentlemen. That's how you do it. See how you start to memorize that formula? It's easier than to just go back and look at what is A, what is B, what is C, and you have to practice. It ain't going to happen without practice. So don't get depressed. What's little a? That's going to be what? 122 squared. What's b? That's 60 squared plus c, 155. Okay, now I'm actually home free. This is 2 times 60 times 155 times cosine of a. So I'm using that format for law of cosines, memorizing that kind of format really, not even memorizing the letters necessarily. And then you're going to solve by translating. Is that true? So what does that mean? That means cosine A, you're going to move that term. And if you move a term, what happens? Changes the signs. And move those two terms. But we forgot some information. If you move it across the equal sign, it's now the opposite sign. So negative becomes positive. Then you get 60 squared, 155 squared, minus 122 squared. Now, what do you guys do? You divide both sides by that 2 times 60 times 155. It goes away on the left, but it stays on the right. So, ladies and gentlemen, this is some solving skills here, okay? And you get 2 times 60 times 155. And then you use the inverse cosine. Inverse cosine of everything you have here. Okay? And I'm back to, again, ladies and gentlemen, putting those parentheses, right? Because I'm going to punch this in the calculator. We're going to punch that in. Okay. I'm going to clear that out. Second, inverse cosine. We warmed up. Put an extra parentheses because this is the numerator. 60 squared plus 155 squared minus 2 times, oops, I messed up. No, minus what? Minus 122 squared. I got to wake up. Close that, divide by, open that. 2 times 60 times 155. Close that twice, okay? Looks like we're good. What do you guys get? Go to the nearest tenths. We're a little bit more accurate today. This is about, A would be what? 46 point what? 8 degrees. Okay, so this is A, 46.8 degrees. So we got the angle A. What do you think we need to do now to get another angle? Again, same thing. Which one do you want to find now, B or C? B? Okay. I'm going to label that what? Red. And this is red. So we're going to get angle B now. So you say, what's the formula for finding angle B? Well, use the law of cosines formula. B squared A squared plus C squared, the other legs, minus 2AC cosine of big B. There's that relationship. This is going to give me B, big B, angle B. So now I do have to go back and look at the letters, though. I have to say, okay, 60 squared, isn't that B? Okay. 60 squared equals, I need A and C now. Oh, A is 122, C is 155. 122, 155. And then use your what again? Use your algebra. Use your translation. So, okay, 2 times 122 times 155 cosine B, 122 squared plus 155 squared minus 60 squared. Okay? So now you get cosine B. What is cosine B? 122 squared plus 155 squared minus 60 squared, everything over 2 times 122 times 155. Okay? Remember how you get angle B? You're going to use inverse cosine again. Okay? And then, ladies and gentlemen, let's take a look. This is going to give me my angle B now. So punch this in your calculator. Second cosine, second set of parentheses, right? 122 squared plus 155 squared minus the 60 squared. Close that, divided by parentheses, 2 times 122 times 155. Close that twice, and ladies and gentlemen, what do you guys get for angle B? To the nearest tenths? It's actually to the nearest tenths. You guys know what that's going to be? No, I think it's going to be exactly what? 21 degrees, right? It's going to be 21 degrees. So you might say then, since that's 21 degrees, really to the nearest tenths, how do I get the remaining angle C now? What do we know again? The sum of the interior angles for any triangle is what? 180. So you can say 180 minus 46.8 degrees minus 21 degrees will give you, what does it give you? I don't know what it gives you. What is it? Let's see, 180 minus 46.8, right? Minus what? 21. And what do you guys get? Is that 112.2 degrees? So, ladies and gentlemen, it's 112 point what? 2 degrees. So this is how you solve a triangle, ladies and gentlemen, by using law of cosines. There's only 2 cases for law of cosines. Side, 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 the one we finished with, and then the other one is what? Side, angle, side. So, of course, what we'll do tomorrow is more law of cosines, but it'll be some applications here. All right, you guys know what I'm saying? Because the reason you do this is for the applications. Anyway, take care. Have a great day. Don't be depressed. And we'll see you guys later.